All right, let's jump right into something that feels, well, just plain wrong. We're going to look at a mathematical proof that seems to completely defy common sense. It's a formula that takes a never-ending line of numbers, adds them all up, and somehow gets 0. Yeah, you heard that right. Get ready because we're about to solve a mathematical mystery.
So here it is. This little gem comes from the mind of the legendary mathematician Leonhard Euler. Just take a second and really look at it. On the left side, you've got this infinite chain of numbers. And, unless x is some very specific negative number, pretty much all of these are positive. So how in the world can they all add up to nothing?
That's the big question, isn't it? How is that even possible? It feels like you're adding brick after brick after brick to a pile. And then when you look, there's no pile. It just doesn't compute. So let's unpack how Euler actually claimed to prove this. To solve this whole thing, we've got to first understand the logic that got us here in the first place. We're going to walk through the proof step by step, and what's wild is how simple and clean it looks on the surface. Okay, check this out. First, we just give the whole long equation a nickname. We'll call it f. Simple enough. Step 2, we multiply that entire thing by x squared. Now, here comes the part that bends your brain. Because this series is infinite, it goes on forever in both directions, multiplying by x squared doesn't really add anything new. It just shifts every single term 2 spots down the line. The result looks exactly the same as what we started with. So the logic goes x squared times f is still just f. And from there, a tiny bit of algebra gets you to a place where f has to be 0. There's no other option.
And that's the thing. Every step of the algebra is, by the book, totally correct. The logic is sound. It feels like this perfectly sealed argument. And yet, you still have that little voice in the back of your head saying, no way, something is wrong here.
And that little voice is right. The reason it feels wrong is because we've been looking for the trick in the wrong place. The math itself, the x's and the f's, that's not where the sleight of hand is happening. The secret is actually hiding in plain sight.
That's right, the ellipses. Those 3 little dots at the beginning and the end of the formula, the symbol we use to represent the whole idea of infinity. That's where all the magic and all the trouble is coming from.
So for this next part, let's zoom in on just those dots. We're about to see how this entire mind-bending proof is built on the foundation of that one single, incredibly powerful idea, infinity.
And when you see it like this, side by side, it all clicks with the dots. When we assume infinity, the proof holds up. But the second you take those dots away and you just have a finite list of numbers, well then the formula is obviously false. It's not even close to 0. This shows the whole proof is a kind of illusion, a magic trick that only works because we're playing by the very strange, very weird rules of infinity.
And this idea that infinity has its own strange rules gets us to the main argument from our source material. The idea that sometimes the most powerful tools in our mathematical toolbox are surprisingly fuzzy when you look at them up close.
The source calls them fantasy objects, and infinity is the perfect example. It's a concept that lets us do all kinds of incredible things in math and physics, but if you try to truly pin down what it is, it gets really slippery. It's a tool that works, even if we're not totally clear on what the tool itself is made of. So, Euler's weird formula that adds up to 0? It's the poster child for a fantastic object in action. It's a proof that is totally logical within its own little bubble, but its connection to the real, tangible world is murky. And it's all because it's built on that slippery, powerful idea of infinity.
Okay, so if using a concept like infinity can lead us down these strange, paradoxical rabbit holes, what's the alternative? Well, the source suggests that maybe, just maybe, we need a new way to talk about these things, especially when we use math to describe the actual world around us.
The proposal is actually a really big shift in thinking. It suggests we could replace a loaded word like infinite with something more grounded, like ongoing. The idea is to give physicists new kinds of tools, maybe hybrid tools, that would let us think about the universe without the built-in biases that our current concepts, like infinity, might carry.
And you might be wondering, okay, this is interesting, but why does it matter to anyone who isn't a mathematician? Well, this debate actually gets to the very heart of one of the biggest questions in physics. Is the universe fundamentally smooth, or is it pixelated?
Think of it this way. A discrete universe would be like a digital photo. If you zoom in far, far enough, you'll eventually see the individual building blocks, the pixels. But a continuous universe is more like an oil painting. No matter how close you get, it's always just smooth, unbroken brushstrokes.
The kinds of math we choose to use can actually push us towards seeing reality as one or the other.
And this is the central warning from the source. It says that it's risky if our mathematical language is built only on one kind of object, let's say discrete numbers, because we might accidentally conclude that the universe itself must be discrete. We could end up mistaking the nature of our ruler for the nature of the thing we're measuring.
So, the takeaway here is actually pretty profound. We started with a strange formula that added up to 0, and we ended up with this fundamental insight. Our tools are not neutral. The very concepts we invent to make sense of the world, concepts like infinity, can end up shaping our most basic beliefs about what the world even is.
Which leaves us with one final, fascinating question to chew on. Is infinity something we discovered out there in the fabric of the universe, a real feature of reality? Or is it something we invented, a powerful, brilliant, and sometimes tricky tool of our own creation?